I am delighted to present our work, When Can LLMs Actually Collect Their Own Mistakes? A critical survey of self-correction of LLMs. Self-correction is a framework that refines responses from large language models using large language models. For example, we can ask large language models to generate feedback on initial responses and make refinements based on that feedback. There are various different definitions for self-correction, but we consider inference time correction that refines responses during inference in this work. The most famous recent advancement in self-correction is OpenAI o1. OpenAI o1 has a capability of recognizing their own mistakes and refining its own thinking processes. o1 largely outperforms existing large language models in reasoning tasks such as mathematical reasoning and code generation. One of the conclusions of our survey paper published in June is that self-correction is still difficult for existing large language models. However, in September, OpenAI published o1 and claimed that o1 can refine its own thinking processes. Does this indicate that our survey paper was wrong? Fortunately, no, because these two claims are for self-correction frameworks in different settings. Our conclusion is about self-correction without doing any additional training. However, OpenAI o1 is trained for self-correction with large-scale reinforcement learning. Therefore, it is possible that both of these claims are valid. The main takeaway from our survey is that we need to be very careful about the settings and hyperparameters of self-correction when we compare the results of self-correction frameworks. Some frameworks use large language models without changing them, but we can also train them specifically for self-correction. Other studies propose self-correction with external tools or information. These frameworks in different settings cannot be directly compared. In addition, there are tasks that are exceptionally suitable for self-correction. When we read papers or reports about self-correction frameworks, we need to be careful about settings of the frameworks and target tasks. Actually, not only readers, but also authors of previous self-correction papers are confused by the complex settings of self-correction. This table in our survey paper shows that previous works in self-correction use different settings in a single paper without explicitly differentiating them. We wrote this survey paper to caution the readers and researchers that we need to be very careful about the settings of self-correction frameworks. Based on our survey, I will explain self-correction in these three different settings. The first one is intrinsic self-correction, which use existing large language models without external tools or additional training. Intrinsic self-correction uses the same models for generating responses and refining the mistakes. There are many variants, but in this figure, the same model performs initial generation, feedback generation, and refinement without additional training. However, previous papers observed that intrinsic self-correction often do not work well and often can degrade performance. Some papers also reported that large language models often cannot detect their own mistakes, and this is one of the reasons why large language models cannot correct their own mistakes. However, there are many papers proposing intrinsic self-correction frameworks. We explored how these papers enable intrinsic self-correction. First, some papers use oracle information during self-correction. For example, some papers stop self-correction if the current answer is correct. This is problematic because self-correction can degrade responses if they generate wrong feedback, as in this figure. We should use a fixed number of iterations or a classifier to determine when to stop the self-correction iterations. In addition, we found that many papers in intrinsic self-correction target tasks that are suitable for self-correction. It is known that error detection is a bottleneck of self-correction. So intrinsic self-correction is often possible in tasks where detecting mistakes in responses is relatively easy. For example, the composable task is one of the group of tasks suitable for self-correction. In this example, the initial task is to generate multiple politicians who were born in New York City. The responses can be easily decomposed into subparts about individual politicians, and self-correction only needs to verify information about each politician. We can expect that verifying information for each politician is much easier than generating all politicians at once. In this setting, we can expect that large language models can detect their own mistakes because the error detection will be easier than the initial generation. The second group of tasks is verifiable tasks. For example, give of 24, which is a task of creating 24 from 4 numbers, is a popular toy task. But we can easily detect mistakes by checking the final answer. This task does not even require an error detection process and are relatively easy for large language models to correct their own errors. As a summary of the first part, our survey concluded that intrinsic self-correction is still difficult for large language models, and large language models often cannot detect their own mistakes. There are papers that propose intrinsic self-correction methods, but they often use unrealistic settings, such as using oracle labels or target tasks that are exceptionally suitable for self-correction. Next, I will explain self-correction using external tools or information. We concluded that intrinsic self-correction is difficult in general tasks because large language models often cannot detect their own mistakes. To overcome this issue, many studies explore self-correction using external tools or knowledge to generate a better feedback. First, previous studies show that large language models often can refine their own mistakes when reliable tools are available. One of the most popular applications of this approach is code generation, which can use executors and unit tests to provide reliable feedback on errors in generated codes. Besides code generation, previous studies proposed to use proof assistant for proof generation, symbolic solvers for logistic reasoning, and responses from environment for tasks in simulated environments to enable self-correction. Next, when we use external information during self-correction, it has been reported that large language models often can detect their own mistakes and refine them. This sounds obvious because the self-correction process uses extra information, but this setting is realistic in many applications. For example, as in this figure, we can use initial responses to generate queries to retrieve additional information. In this framework, the self-correction process receives additional information to update initial responses. Previous studies often use web search or database such as Wikipedia as external information. Finally, there are many studies that apply additional training specifically designed for self-correction. We concluded that intrinsic self-correction without additional training often does not work. Many studies explore additional training designed for self-correction. And they reported that self-correction works when good training data is available. Dataset creation is a major challenge in this approach, but previous studies proposed self-correction with supervised fine-tuning or reinforcement learning and reported positive results. In summary, we concluded that intrinsic self-correction does not often work because large language models often cannot detect their own mistakes. However, there are tasks that are exceptionally suitable for self-correction, such as the composable tasks. It is also known that self-correction works if external tools or information suitable for detecting mistakes are available. Additional training is another promising approach to enable self-correction, and OpenAI O1 is also taking this approach. The most important message we want to tell in this survey is that we need to be very careful about the setting of self-correction. Self-correction works very differently on different tasks, and its performance is largely affected by external tools, external information, and additional training. We already know that comparing performance of large language models is challenging, but comparing self-correction frameworks is much more challenging and complex. We hope this survey will help researchers properly categorize and organize their self-correction frameworks so as not to confuse readers and the researchers themselves. Thank you for your attention.